Let me introduce Envia Path, alignment optimization program applying state-of-the-art information and communication technologies. I will begin by giving you a brief outline of advantages and core functions of Envia Path. The conventional alignment design requires intuitive judgment heavily relied on experienced engineers and repetitive manual modifications. Due to these constraints, only 3 or 4 alternative routes can be generated. Whereas, by scoping input data and design considerations, multiple investigated alternative routes can be generated using Envia Path, thanks to rapid automated alignment generation. This improves productivity by shortening the time required at the planning phase of roads and railways. Envia Path is an automated design program using artificial intelligence algorithms. Horizontal alignment, vertical alignment, cross-section, and right-of-way are generated automatically, and various reports are produced. It is possible to reduce the project cost by selecting an optimal route based on construction cost parameter among hundreds of thousands of alignments. Let's move on to Envia Path design process. Design process can be divided into 4 stages: data input and setups, automated alignment generation, optimization of alignment, and 3-dimensional driving simulation. Envia Path gives the world's best performance with automated software for roads and railway planning. Data input includes contours with height values for survey, digital topographic maps, terrain, DEM, or digital elevation model, the basic conditions such as roads, rivers, and villages, any planned roads or railways, important transit points, control points, must-avoid zones, and so forth. Status and constraints such as the speed of the design criteria, cross-section, the start and end points are also set to be defined. Unit cost by construction work can be adjusted appropriately for each country. As you can see on the screen, this shows that database is completed. The red line indicates direct distance from the start point to the end point, and the white lines are the roads and railways. The yellow polygon means control point settings, and cyan lines represent streams. In the stage of automated alignment generation, we will show you the process of creating alternatives that considers the social aspects of regional development and requirements from stakeholders. Now, Envia Path is investigating hundreds of thousands of horizontal and vertical alignments, utilizing artificial intelligence algorithms. Next, we will move to the hilly area. The first corridor has easy access to the existing road and urban areas, and it is feasible to make a detour around the mountainous areas. The second corridor shortens the driving time, so the mobility improves better. However, it requires numbers of structures to be constructed. The third corridor is economically feasible that conserves natural environment and minimizes civil complaints and installation of structures. In this way, various options of preferred corridors are provided by scoping terrain and other constraints, such as construction cost and environment. Now, we will move on to the area of rough terrain with mountains. Traffic safety is advantageous for the Corridor 1. However, too many structures are required to ensure drivability. For Corridor 2, curvature should be increased in the alignment to minimize damage to the original topography. Unlike the hilly area, for the rough mountainous terrain, there are not many options of preferred corridors taking the smooth traffic flow into account. In the optimization of alignment phase, we will show you how to optimize alternative routes by grouping corridors and evaluating construction costs and selecting the preferred alternatives. The images show the process of grouping each corridor, and the optimal alignment and longitudinal alignment are derived for each group. As you can see on the screen, in some sections, 3 or more route groups are shown, whereas only 1 or 2 route groups appear in other sections. You can check the location of the bridges and the tunnels from the longitudinal section. With the selected preferred alternatives from each group, the comparison table is made up so that you can compare the length and construction costs at a glance. Now, it is the grouping process by evaluating construction costs, and it finally provides the optimized alternative routes for decision-making. The final stage, 3D driving simulation, allows visual and objective judgments on alternative routes, and finally, validates the route with better technical, environmental, and scenic characteristics. It is possible to adjust the eye level and the running speed, and realizes the internal landscape of the road, as well as the harmony of the horizontal and vertical alignments from a driver's perspective. It can also identify the problems in advance. You can check the influence of the large cut slope and high landfill slope condition on the surrounding environment. Envia Path Alignment Optimization Program reduces the planning time by creating hundreds of thousands of alignments with automated design, and saves the project cost as well, because Envia Path generated alignment will cut the construction cost by avoiding constraints. Thank you.